I realized that there were a lot of extreme outliers beyond the upper whisker value of my box plots as seen here of the variables bounce rate and exit rate, which could distort and reduce the accuracy of my statistical analysis and models by making them skewed. So to fix this, I used K9 with the math formula node to normalize them by performing log transformation to reduce the extreme outliers and skewedness to make them more readable and better for more accurate data analysis and modeling. So the durational data that visitors spend on web pages also had a lot of outliers, as it can be seen on this histogram, with some visitors having up to 16 hours on a single page. So since this is clearly abnormal behavior, I rule them out as bots, anomalies, or administrators who are not the target for data analysis, as I want to find trends of typical user behavior that can be useful. So I use the statistic view node to look at the 99th percentile of these variables and use the rule-based row filter to filter them off at this 99th quantile, so that I can filter off the anomalies without losing the useful data as much as possible. So I lost 337 rows of data, going from 12,328 to 11,911 rows, but decided that this was necessary to create a more concise and relevant data set, which will give me more useful data analysis on typical user behavior. I then used the rule engine node to sort the special day variable into three categories: no special day, approaching special day, and special day, as they were in numeric form ranging from 0 to 1, which was hard to interpret. So this will make it more interpretable and easier to analyze, since it will be less skewed. Since there were a lot of zeros in the data set, I would have ended up with a distorted data set if I used it as is. So by doing this, it will give me better statistical analysis and modeling without such skewed numeric data. Since my data transformation is complete, I'll export it for use using the CSV writer for use in further analysis and modeling in Tableau. So to answer my investigative and further insight questions, the first question is, does spending more time in the informational web section result in a lower bounce rate from the site? So to answer this, I plotted a scatter plot to find the correlation between the two variables. So with the trend line, I can see that the correlation between these two numeric values, there is a negative correlation between them, but looking at the R-squared value, 0.008, it's so small, it's so weak, that it's basically negligible. So I can conclude that they basically have no correlation, and what drives the bounce rates lies in other factors, so I should focus on analyzing other variables to find useful trends to me. The second question asks, does a longer duration spent in the administrative web section correlate with a higher exit rate? This scatter plot shows a negative correlation as well between the time spent in the administrative web section and the exit rate. However, the R-squared value is also extremely low, with a value of 0.0685. So low that it's basically negligible as well, and I can again conclude that there is basically no correlation, and that the drive for exit rates lies in other factors that I should focus on analyzing. Question 3 asks, is there a seasonal pattern in revenue generation across different regions, particularly in specific months? So after analyzing the graph, I found that China and US bring in the most traffic, especially in the months of March, May, November, and December, with the highest percentage of revenue-making visits occurring in November. This tells me that seasonal trends or holidays such as Chinese New Year, the 11/11 sale, and Christmas are key driving forces to whether a visitor makes a transaction or not, and the website owner can take advantage of this knowledge to prioritize marketing efforts and cater more towards these regions to gain more visitors and make more revenue. However, revenue-making visits make upon an average Revenue making visits make up an average a tenth of the monthly visits, which suggests that there is a strong deterrent that discourages these visitors from making a transaction. It may be a lack of localized payment methods or poor user experience, but the most likely problem seems to be high shipping costs or delivery times, as a very big amount of traffic comes in November, where people tend to buy items or presents in bulk in view of the upcoming holidays, so that they can save on shipping by buying everything together. Question 4 asks, how does the time spent in the product related section, the type of traffic source, and the likelihood of a transaction interact? So I plotted a bar chart to see the visitors from which traffic type spend the most time on product pages, and a heat map to visualize the ratio of which traffic types bring in the most revenue making visitors and to visualize which traffic types bring in the most revenue making visitors and the ratio of revenue to non-revenue making visits. I can see that the organic search, paid search traffic, and direct traffic bring visitors with the highest time spent on product pages, which tells me that these traffic types are the most effective at bringing in interested visitors who have potential to make a purchase. The heat map shows that organic search traffic and paid search traffic bring in the most transactions. These traffic types are the most effective in bringing in the largest volumes of meaningful traffic or visitors interested in the web page's products, spending the most time browsing and being more likely to make a transaction. Knowing this, I know that these traffic types should be invested in more to attract more desirable visitors. So question 5 asks, does the visitor type influence the average page value on special days and holidays? Looking at the bar chart, a large chunk of other visitors make up the visitors on no special day, which I'll assume are just website administrators, as they will be visiting the website extremely often on working days, away from special days. So I'll ignore them as I want to analyze the trends of typical user behavior. So the total average page value on normal days approaching the peak when special days are coming up with new visitors. The total average page value peaks on normal days, approaching the peak when special days are coming up with new visitors having the largest influence on page values and driving the largest average page values across all three of the special day proximity categories. Returning visitors do not have as much influence on the average page values compared to new visitors, and new visitors have the highest influence on it when approaching a special day, which makes me believe that the average page value is mostly driven by first-time gift shopping or opportunistic browsing of new visitors. Last-second shopping may also be a driving force. Question 6 asks, which traffic type has the highest transaction rate? Which can be plainly seen in the stacked bar chart over here, that organic search traffic is brings in the most revenue, with paid search traffic, direct social media traffic bringing in the following largest amounts of revenue making traffic. Paid search traffic brings in the second highest amount of traffic but has one of the lowest revenue making traffic proportions, while display ads traffic brings in the highest proportion of revenue making traffic, though it does not bring in significant amount of traffic. These are all traffic types where visitors are intentionally looking for something and click in to the website intentionally, which tells me that the product and content of the web pages likely meet what the visitor is looking for. But the low transaction rate of paid search and direct traffic suggests that users are dissatisfied with something and there is room for improvement that the website administrator should look into. On the other hand, display ads and retargeting traffic have a higher revenue generating proportion despite the low traffic they generate and should be tested, invested more in to see if they bring in more traffic and revenue, as they seem like more ideal traffic sources for customers that are desirable. Question 7 asks, is there a correlation between the duration spent on product related pages and the likelihood of making a purchase? So the scatterplot trend line shows a positive correlation between the time visitors spend on product related pages and them making a purchase, but the R-squared value is a measly 0.0304, which is negligible, telling me that there is no strong relationship between these factors and that the driving factors of a transaction occurring lies elsewhere. So moving on to my data modeling, I want to build and evaluate a predictive model that can make accurate predictions based on the data set to figure out which variable and what conditions are most likely to drive a successful transaction. The transformed and clean data is fed into the partitioning node to be split into a 75-25 split of training and test data, where I chose a 75-25 split since my data set was moderately big with about 10k rows of data. From my investigative and further insight questions, I found that the month, region, and proximity to special day and whether it was a weekday or weekend were the biggest drivers to driving a successful transaction making visit. So I selected these for training use and selected revenue as the target for the train prediction model. I then used the logistic regression predictor node to use the test data set from which I split from the partitioning node to compute predicted outputs for each row and evaluate the model's accuracy. The numeric scorer then takes this predicted output and compares it to the actual numeric value from the test data from the partitioning node to compute performance statistics in numeric data, where I can see that there is an 85% accuracy in the train prediction model.